Inverse function notation. So given a function, y is the function of x, the inverse function is written as y is the inverse function of x here. So here in the following examples we want to write down the domain and the range of our function, of the original function. Then find the inverse relations and find the domain and the range for the inverse relation here. So here, for our original function, the function of x is equal to 1 divided by x plus 2. So here if we look at our domain will be all real x not equal to 2. We undefined here, so negative 2, at x is negative 2. And our range will be all real y not equal to 0. So now to find our inverse relation here. So we can say, well, let y equals 1 on x plus 2. So we interchange. So x is equal to 1 on y plus 2. So we switch these over. Y plus 2 is equal to 1 on x. Subtract 2 from both sides. Y is equal to 1 on x minus 2 here. So we write here our inverse function of x is equal to 1 on x minus 2. For this one here, our domain will be all real x not equal to 0, as we're undefined at this point. And for our range, 1 on x can't be equal to 0, so 1 on x minus 2 not equal to minus 2. So we're going to have here, our range will be all real y not equal to negative 2. So for our next example, we look here, our original function here. Our function of x is 2x minus 1. So our domain will be all real x. Our range will be all real y. So now we're going to find our inverse. So we say let y is equal to 2x minus 1. If we interchange, x is equal to 2y minus 1. Add 1 to both sides. X plus 1 is equal to 2y. Divide both sides by 2. Y is equal to x plus 1 divided by 2. So our domain will be all real x. And our range will be all real y. So to prove whether two functions are inverse pairs, we often want to prove if they're inverse pairs here. We use our following relationship. So here the functions f of x, function f here, and function g of x are inverses if the function f of g of x is equal to x, and the opposite, the function g of f of x is equal to x, are true. Or using our inverse function technology, we have our function of x and our inverse function of x. And so if the function of the inverse function is equal to x and the inverse function of the function is equal to x, then it is true. So what we're going to do is use this example here. So what we want to find, so if we write up here what we want to actually do. So we're going to find, well, here function g of x here equal x, and here g of f of x is x here. So we're going to work on this one first. So here we know, well, g of x plus 3 on 2. So we substitute this value into our x for our f of x. Here f g x here, so 2 x plus 3 divided by 2 minus 3. So if we expand this out, we've got 2x plus 3 on 2, So our 2's will cancel, minus 3. So we have x plus 3 minus 3 is equal to x. And conversely here, so we know, well, function f of x is 2x minus 3. G f here, so we substitute this in to here for our g function here, 2x minus 3 here plus 3 divided by 2. So here 2x minus 3 plus 3 is just 2x. On 2, these cancel, is equal to x. So we can prove here our functions here. So therefore these two functions are an inverse pair.